Grüezi YouTubers. Here is the guy with the Swiss accent again.
Sometimes you need more than just one I2C devices like displays and pressure or acceleration sensors for your project, and your Arduino board has only one I2C connection. In this video, I will show you how to reach your goal. I2C is an abbreviation for I2C, which means inter-integrated circuit. And it is not a one-to-one connection, but it is a bus system. In electronics, bus systems are used to connect multiple similar devices. Each device has to follow some rules, and all devices have to have at least one difference. Otherwise, it would be impossible to distinguish between two devices connected to the same bus. The I2C bus uses an 8-bit address to make the difference between the devices. This enables to distinguish between 255 different devices on the same bus. If you want to talk to a particular device, you have to call it by its address. The I2C bus is a serial bus. Opposed to the parallel buses, serial bus systems use only a few wires. In the I2C case, 2 wires are needed in addition to the power supply, VCC and ground. These 2 wires are called SDA and SCL. SDA carries the data and SCL the clock signal. The I2C bus allows 2 different roles. Even if these names might not be politically correct, they are called masters and slaves. Arduino's ESP8266 and STM32 boards talk to the I2C bus through the wire library, Attiny's through the tiny wire library. Now we have all ingredients to draw a whole I2C system. Your Arduino is the master. SDA and SCL wires are connected to the respective pins, and the slave devices like the sensors or displays are connected to the same wires. The SDA and the SCL pins vary from Arduino to Arduino. The Uno, for example, uses A4 and A5 pins. For my project, I built a small bus for DuPont wires. I use colored pin headers, connected all pins in one row together, and enclose the bus with a heat shrink tube. At the end, I fill it with hot glue. The result is a simple and effective I2C bus. We can use the I2C bus on 5V or 3.3V level. However, if we need to mix 5V and 3.3 devices, we have to use so-called level shifters. Readily made modules are available in the internet. We can extend the bus on both voltage levels. To show how it works, I built a small I2C bus system consisting of 2 OLED displays, a BMP085 pressure sensor, an MPR121 touch sensor, a level shifter and 2 homemade I2C buses. If we want to talk to a slave on an I2C bus, we need to know its address. Often you find this address in the documentation. Fortunately, the usual sensors in the Arduino field all have different addresses by design. This means you have no problems connecting one device of a kind to one I2C bus. Even if I know the address, I first connect each new device to the bus and start a small sketch called multi-speed scanner. This sketch runs on Arduinos and scans the I2C bus and displays all addresses it finds. With this step, I can check if my wiring is okay, if the devices work, and its real address. So let's start the scanner. After uploading the sketch, I first press the letter P to display only the addresses with devices. Then I press S for single scan. The result are 4 different addresses. 3C for the first OLED, 3D for the second OLED, 5A for the MPR121, and 77 for the BMP085. I will explain in a second video why the 2 OLED have different addresses and how to deal with it. In this video, I will only use 1 OLED. So we have an I2C bus with a touch sensor, a pressure and a temperature sensor, and a display all connected to one I2C bus. Awesome. Let's play with it. If I touch the pin 0 of the touch sensor, the display changes the value from pressure to temperature. And if you are familiar with the weather conditions here in Switzerland, you could see from these 2 values that today we had a warm day and tomorrow we will have bad weather. And everybody can see that all 3 slaves are working together with a master and on 2 different voltage levels. And for the guys on other hardware, what was said here works also for Attinys, for ESP8266 and for STM boards like the Maple Mini. To be complete, I have to say that I did not cover I2C speeds and bus termination. If your wires are short and you do not connect too many devices, these topics are not important for you. Otherwise, Dr. Google knows more. I would be interested which projects you are building with many I2C devices. Just enter your thoughts into the comment below. If this video was useful or interesting, you can subscribe my channel. Then you will be informed when I upload a next episode about 2 equal sensors or displays on the same I2C bus. Bye.